Bismillahirrahmanirrahim. Today we are going to start first session of our lecture number 3 in operating system course. Before to start our third lecture, we will just take a quick overview of our second lecture that we finished in last week. That lecture was based on the first course learning outcome, recognize operating system history, services, application and types. In this lecture, we start our discussion from random access memory. And in this course, we have seen that this is a type of memory that can be accessed randomly. So we can access this randomly any byte without touching the preceding byte. So computer program must be in main memory or RAM to be executed. So if you want to execute any program, so it's very important that this program must be in main memory. Then we have seen the type of RAM, and we have two main type of RAM that we already have discussed, the DRAM and SRAM. DRAM means dynamic random access memory and then static random access memory. We also have seen that these type of RAM differ in technology because the purpose of the RAM is to hold the data, to store data. So they have different technique to store the data. And then we have seen some main differences between SRAM and DRAM. And we said SRAM is faster than DRAM because dynamic random access memory need to refresh thousands of times per second. It requires refresh. So that's why this SRAM is faster than DRAM. But at the same time, SRAM is more expensive than DRAM because this is not commonly used. Commonly used RAM is DRAM, and we have seen that both type of RAM are volatile, meaning that they can lose their content when power is turned off. When we will shut down our system, they will lose all the information that is available in RAM. Then we have seen read-only memory, and we have said that read-only memory is a class of storage that in computer that is used in other electronic devices, and the data which is stored in DRAM, it can be modified very slowly, difficulty or not at all. It's very difficult to modify the information which is available in read-only memory. Mainly this read-only memory is used to distribute the firmware, the software which is closely related to the specific hardware. So it is used to distribute that hardware, that software. Then we have seen computer system architecture. In architecture we have seen that we have single processor system and multiprocessor system. Single processor system has only one main CPU that is capable of executing general purpose instruction set. So here we have only one CPU, main CPU, and it is executing all our process. But in the multiprocessor system, the number of processors are 2 or more. They are in close communication and they are used to execute the computer program, process and instruction set. So we have seen some advantages of multiprocessor system. We have seen it is increased throughput, economy of scale and increased reliability. So what is increased throughput? That by increasing the number of processes we can expect to get more work done in less time. So if we increase the number of processors, then our work will be finished more quickly than if we compare with the single processor system. Second advantage, we have seen that economy of scale. Multiprocessor system will cost less because they are sharing the different resources of computer like peripheral devices, mass storage and power supplies. Then we have seen the third advantage, the increased reliability. Multiprocessor system are more reliable than single processor system because If in multiprocessor system, if one processor is not working, the remaining will continue work. It makes possibility the work will be slowed down, but it will give us some reply, some output to the user. Then we have seen multiprogramming. Multiprogramming, which is a technique used to utilize maximum CPU time. Actually, what is multiprogramming? To execute more than one program at a time. So if we want to execute more than one program, so it is multiprogramming. The purpose of multiprogramming is that we don't want that our CPU become idle. So we want to use the CPU as much as possible. So here one example is discussed that we have 4 jobs in our memory and how to execute these jobs. Then we have discussed the dual mode operation. In dual mode operation we have seen that we have 2 types of mode in our computer, kernel mode and user mode. When the operating system have full control of system, it is called kernel mode, and whenever user process have control, so it is user mode. So we can shift from user mode to kernel mode and kernel mode to user mode by setting the mode bit. If mode bit is equal to 1, it means we are in user mode, and if mode bit is equal to 0, it means this is kernel mode. So process of moving from user mode to kernel mode, it is called trap, but the process of moving from kernel mode to user mode, it is called return. So this was our second lecture. Now we will start our lecture number 3. So it is first session of this lecture. So we will complete this lecture number 3 in 2 sessions. So this is first session. This lecture also based on our course learning outcome 1, that recognize operating system history, services, applications and types. Okay, timer. As we know that timer is very important in our life. We are using our timer everywhere. In morning, if we want to wake up, we are using timer. If we have any specific task to do at specific time, so timer also help us. In same way, a timer can be used to interrupt the computer after specified period. So we are using timer in our computer. Why we are using, in next slide we will discuss why we need timer. But what is purpose of timer? The purpose of timer is to interrupt the computer. So we are interrupting the computer after some period. So we have 2 types of timers that can be fixed and variable. Fixed, that is fixed. We are not changing. For example, 1 by 60 seconds or 1 second or 10 seconds, 10 minutes. This is fixed. Like our class time, this is 60 minutes. So we are not able to prolong. In exceptional cases we can, but this is fixed. This is a duration that we have to follow. But in variable timer, this time vary. For example, here from 1 millisecond to 1 second. So we have always 2 types of timers, fixed and variables. So what is in simple, we can say that timer is used to prevent a user program from running too long, because it is possibility that user program is running and it is taking too much time and not giving control back to the computer. So timer is very important. So here, why timer? Why it is important? The main objective of timer is to ensure that operating system maintain the control over CPU, because there should be something that give control back to operating system. So timer will help us. So we will see next slide how we can implement the timer. So it is possibility that user programs getting stuck in infinite loop. So there is a loop, infinite loop, and it's not giving control back to the operating system. So we use timer to get the control back. So how? It is implementation of variable timer. How we can implement this? To implement variable timer, we need two things. First one is fixed rate clock and counter. So what we need? We need fixed rate clock and counter. And what is counter? Counter is actually a variable that we will declare. And we will use clock to use our variable counter. So what operating system will do? The first task, the operating system set the counter. It will set the counter. Suppose we say that counter is equal to, we suppose it is 5. Okay, counter is 5. So operating system will set the counter any value, 5 seconds, 5 milliseconds, 10 milliseconds, or anything. Now we will see the clock. Every time the clock excuse me, every time the clock tick, the counter is decremented. One time when the clock will tick, we will decrease the counter from 5 to 4. So every time. So when next time it will tick again, so we will decrease to 3. Then we will decrease to 2. Then 1. Then 0. So every time the clock will tick, so counter is decreases one time. When the counter reaches 0, so when it will be 0 here, then we will stop. So what operating system will do? Timer will interrupt the computer and it will give control automatically to the operating system. So this is the way to give the control automatically back to operating system. So if user have written any code, that code have some bug or some problem and it's stuck in infinite loop, so system will not become halt. It will give control back automatically to the system. So what we have seen, timer. What is timer? Timer is used to interrupt the computer after specified period of time. Okay, so we have two type of timer, fixed and variable timer. So why we need timer? Because the timer is used to ensure that the operating system will maintain his control on the CPU. So how we can implement timer? We can implement timer by using two things, fixed rate clock and counter. So there are 3 steps we will do. First, the operating system will set the counter with some values like we have given here 5, and when the clock will tick, we will decrease the timer, and when the counter will reach to the 0, then control will be automatically transferred to the operating system. Okay, next we have some type of operating system. There are main 5 type of operating system: multitasking and single tasking operating system, multi-user and single user operating system, distributed operating system, embedded system, and real-time system. So we will discuss all these 5 type of systems, operating system, one by one. So first one is multitasking and single tasking operating system. As the name shows, single and multi. So in single tasking operating system, when a single program is allowed to run at a time, when we are able to run only single program at a time, so this type of system is grouped under single tasking operating system. Mean they can perform only one task at a time, not more than one. Okay, so in single tasking operating system, only one program is allowed to run. But in multitasking, uh, we can execute more than one task at a time. So multiple tasks at same time. This is called multitasking. Operate multiple tasks at one time. So we multitasking can be of two types. So there are two types of multitasking that we can use. That is, first one is preemptive multitasking and second is cooperative multitasking. So in preemptive multitasking, the operating system is making the slice of our CPU time and then it gives one slice to one program. Okay, so like our class time, is 60 minutes. So this time is from 8 to 9, it is for operating system course. So from 9 to 10 maybe you have another class, 10 to 11 you have another class. So your time is divided. In same way, in preemptive multitasking, operating system divide the CPU time and it give one slice to each program or each process. So we will see in next this program it become process when it is in main memory. But in cooperative multitasking, that is opposite. The program currently in control of process retain the control. It will keep the control until it yield the control to another program voluntarily. Now here in preemptive approach we can force the program to stop and give control of our processor to another program. But in cooperative it's not possible because it depends on the program. If voluntarily it is releasing processor, then it's okay, otherwise we are not able to take the control back. So what is multitasking and single tasking operating system? In single tasking operating system, only one program is allowed to run. But in multitasking operating system, more than one program it's possible to execute at the same time. So then we have seen two type of multitasking, preemptive and cooperative. Okay. Next type of operating system is multi-user and single-user operating system. Like the multitasking and single tasking operating system, here in single user operating system we have only one user, and in multi-user operating system we have more than one user. So in multi-user operating system, it allows multiple users to access the computer system concurrently because at the same time. So at the same time multiple users are able to access the system. For example, the time sharing system that are classified as a multi-user operating system as they enable a multiple user access to a computer through sharing of time. So what is actually behind it is sharing of time. So time is shared among the different user, and it is in very high speed, so we are not able to see that it is, because switching is very in too much speed. So multi-user operating system are used on network of computer. Whenever there is a network, the computers are connected in the network. So that is example of multi-user operating systems. Multi-user operating system allow many different users to access the same data and application on the same network. Okay, so it's not necessary that we have all the application, all the data on my local machine. So if we are connected with the network, so we can access the data and application from any other user, from server, from anywhere, if they are connected with each other. So also the multi-user operating system, they also allow the user to communicate with each other. So this is These are the some points related to multi-user operating system where the number of users are more and they are accessing the data concurrently. At the same time, they are accessing data, application and everything that on the system which are connected with each other. Also, they can communicate with each other in this way. Okay, so single user operating system are opposite to the multi-user operating system. They are usable by only single user at a time. So what is the example of this system? That our home computer, our computer in office. So these are the example of single user operating system only we are using. Nobody other is able to access our system. So this is example of single user operating system. Then we have another type of operating system which is called distributed operating system. In distributed operating system, as its name shows, that it is distributed in different locations. Okay, so an operating system that manage group of independent computer. So independent computer we are able to manage here. Okay, how the development of network computer that could be linked and communicate with each other. As we have seen, the multi-user operating system, the computers are connected with each other, and this connection may be physically through cables or through wireless. So they are connected with each other and they are communicating with each other. So what is distributed operating system? It is used to manage a group of independent computers. In distributed system, it's possible that software and data may be distributed around the system. Program and file may be stored on different storage devices which are located in different geographical location or may be accessed from different computer terminal. Okay. Now it's possibility that all the data or software not stored on single computer. So we can access data from different location. Suppose this university have another campus in another city. So maybe some data is stored on over there. So we can access that data through connection, through wireless link or through internet. We can access that data. So it is not necessary that we have all the data, all the software which are installed on my local computer. So if our operating system is distributed operating system, so we can access the data very easily from the remote location, from the different location. So the another type of operating system which is embedded operating system. Embedded, its meaning shows, if you see the name embedded, something is already built in. Okay, so these type of operating systems are designed to operate on small machines like PDAs, your smartphone, your tablet, all these machines. They have some embedded operating system. One of the advantages of these embedded operating system is that they can operate with the limited number of resources. They don't need too much resources. With the limited number of resources, as an example, if you see your smartphone, they have operating system, and it is not necessary that you have 10 GB memory in your mobile, then it will install and it will work. No, with the limited number of resources, with limited number of memory, speed and everything, they can operate very efficiently. Also, these type of operating systems are very compact and very efficient by design. So they are very efficiently they can work. So again, if you see the performance of your smartphone, okay, so all these type of machines, small machines, they are using these embedded operating systems. For example, Windows CE is an example of embedded operating system. FreeBSD and Minix 3 are some example of embedded operating system. Also, you have Android and in Apple they are using their own operating system. So all these are example of embedded operating system. And important thing is embedded operating systems are used to operate the small devices like PDAs and these type of things. Our last type of operating system is the real-time operating system. It's a multitasking operating system that aims at execute real-time application, because sometimes we have real-time applications, so we want to execute these real-time applications. We need that our system has capability to execute these type of applications. Okay, real-time operating system use specialized scheduling algorithm. There are some specialized scheduling algorithm, and also these type of operating system quickly respond to the event. Let's suppose if you go to the door which is automatic, and if you are going in front of that door, it's automatically open. So it means this is real-time application. They are using some real-time application. Whenever the sensor is getting the signal that somebody is in front of the door, it's automatically open. So mainly these used to control the complex system that require lot of processing like machinery and industrial systems. So we are using in industry where we have some complex calculations. So real-time systems are used over there. So these type of systems we are also using in our daily life, like door. We have in different shopping mall, you will see the real-time applications they are using. Okay, so these are the brief overview of the main different type of operating system. So what we have discussed, that we have 5 main type of operating system, and which are multitasking and single tasking operating system, multi-user and single user operating systems, distributed operating system, embedded systems, real-time operating system. Okay, so this was our first session of lecture number 3. We will continue our second session of lecture number 3 in next class, and that will be related to process. So just we will take a quick overview of our today's lecture, that we started with the timer, and we said that timer is used to interrupt the computer. That like in our life we are using timer to interrupt us, because without timer it's very difficult to finish our task, because time, it's very important. Time is money in our life. So operating system is also using timer to interrupt the system, interrupt the computer. So we have two type of timer, fixed and variable. Fixed is fixed. Whatever time we will give, it will be fixed. But variable timer, it vary from in the range. Suppose here given 1 millisecond to 1 second. And next we have seen why we need timer. Because we want to ensure that operating system maintain the control our CPU. Because to control our CPU, it's very important. Because in last lecture number 2 we have seen we have two type of modes, user mode and kernel mode. And if control is not going back to operating system, then it will be a problem. Maybe system become halt. Like here one example is given for infinite loop. Maybe user have written a program and our system is stuck in infinite loop. So that is problem. So to save ourselves from this type of situation, timer is very important. And we have seen that how we can implement the variable timer. So to implement variable timer, we need two things: fixed rate clock and counter. So operating system, what it will do, it will set the counter, it will give some initial value to the counter, and then it will look toward the clock. When the clock will tick, the counter will be decremented. When counter will reach to the 0, timer will interrupt the computer and control will be automatically given back to the operating system. So this is a 3-step procedure how we can implement the variable timer in our system. Then we have seen the 5 different type of operating systems: multitasking and single tasking operating system, multi-user and single-user operating system, distributed operating system, embedded operating systems, and real-time operating system. And in multitasking operating system, we have seen that multiple tasks can be done at a time. But in single tasking operating system, it is not allowed to run more than one task at a time. Only one task will be allowed at a time. Then multitasking, there are 2 types of multitasking: preemptive and cooperative. In preemptive approach, we may divide the CPU time in small slots, small slices, small portion, and we give each portion to one program. Okay, and then if the time slice expire, then we can stop a program and we give that slice to another program. But in cooperative, that is opposite to the preemptive approach, because here if a program is voluntarily giving control back, then okay, otherwise we are not able to take the control back from the program by force. Then we have seen multi-user and single-user operating system, and it is allow multiple users to access the computer system concurrently in single use. So time sharing system is an example of multi-user operating system, and multi-user operating system are used on a network of computer. So network, so it means this is multi-user operating system. So we are accessing same data application on the from different computer on the same network. And also multi-user operating system allow that user can communicate with each other. Single user operating system is example is our computer, home computer, office computer, and some other work environment that are not connected with each other. So we are not sharing our data with other computers. So these are single user operating system. Then we have discussed distributed operating system, which are used to manage group of independent computers, and they are also linked with each other and they can communicate with each other, and the data and software maybe they are distributed around the network and they are accessing them. Then we have seen the embedded operating systems. These are installed on our smartphone, our tablets, our PDA, all the small devices that we have. We are using these type of operating system on these devices, and because they can operate with a very low number of resources, and they are compact and very efficient. And examples of these are Windows C, FreeBSD, Minix. These are some common examples that we have in our these small devices. Then we have real-time operating system. So the purpose of the real-time operating system is to execute real-time application. So these type of operating system, they are using some specialized scheduling algorithm, and these type of operating system which quickly respond to the events. If the event occur, so it will be quickly respond to those events, and mainly they are used to control the complex system, and because they require lot of processing. So if you have any question and any suggestion to improve our lecture, so you can send me email on my email address, or you can visit my office during my office hours. Thank you very much, and see you the second session of our lecture.